Operation Shooter is a game I devised that is targeted at Key Stage 3 students and aims to improve their ability to apply various mathematical operations in the correct order to achieve the correct answers in accordance with BODMAS. Students are required to have an understanding of various operators and math symbols. Upon selecting the Start button, the player is taken to the difficulty page. Here, the player can learn how the game works by selecting the book icon that will display a rough guide. After understanding the basic concepts, the player can select one of the 3 difficulties. Once a difficulty is selected, an asteroid will be hurtled towards the player. They must submit an answer to the equation given within 5 seconds, which will launch a missile to destroy the asteroid. The gauge on the right hand side displays the remaining time the player has to submit a correct answer before the game is over. If the correct answer is given, the player will be awarded with 100 points and a tick will be displayed. If the incorrect answer is given, a cross will be shown and the asteroid will continue to hurtle towards the ship. The player can submit as many incorrect answers and the asteroid can still be destroyed provided they submit the correct one within the time frame. The player can restart the game by selecting the restart button and the points achieved will be displayed on the right hand side. The highest score from the 4 rounds will also be displayed and updated after each of the 4 games. The back button can be selected at any time, which will take the player to the difficulty page. Answering a question correct may also trigger 2 different types of power-up, which, if selected, will award the player with an additional 150 points or slow down the rate of the asteroid. If a particularly hard question cannot be answered by the player, they may also be given a power-up that instantly destroys the asteroid if they are lucky, but with no point wasted. The player has 4 games to achieve as high a score as possible. The speed of the asteroid continually increases unless the asteroid slowing power-up is gained. The asteroid slowing power-ups are unique as they slow down the asteroid for all the games. Therefore, special care should be taken to receive these. Collecting as many of these in previous rounds gives the player the best chance of scoring highly in the last round. Displayed here is the code that runs the easy difficulty game mode. In the startup function, variables A2, B2, and C2 have been created that produce random whole numbers from 1 to 10. These have been used to formulate 10 different question formats. As it is an easy game mode, only the addition, subtraction, multiplication, and division operators have been utilized, the latter 2 more sparingly. Brackets have also been included to change the order at which the player must implement each operation to secure the correct answer. A variable labeled app.r has been created with the rand function that generates a random number from 0 to 100. 10 if statements have then been used to dictate which question is asked based on the value of app.r. For example, if app.r is between 0 and 10, then a string of the first question is displayed. A for loop is also implemented, which counts down from 5 to 0, displaying 5 separate images of the asteroid approaching the spaceship. If nothing is done by the player, a series of images will be displayed, one after the other, which will show an asteroid hurtling towards the player until the app.gauge.value is equal to 0, in which case the game over label will appear, and the game over audio will be played. In the function check answer button pushed are if and else if statements. For example, if the value of app.r is within the 0 to 10 range, the gauge value is not 0, and the answer given is equal to that of the question displayed, then func_app will be called. If the app.r is within the 0 to 10 range, but the answer given is not equal to the answer of the question displayed, then func_2_app will be called. There are more if statements below that express the same thing for the different app.r ranges. Some of the conditions also include lines of code that make the certain power-ups visible, so that when they are pressed, it runs the function for that particular image callback. Func_app is the function called when the correct answer is given. The function displays the tick image and the plus 100 image. It also updates the value of the edit field box, which stores the current score. The if statements below ensure that the correct asteroid explosion image is shown. The func_2_app function is called when the incorrect answer is given. It displays the images of the asteroid approaching the ship by turning the relevant images on and off with the pause function used in between. If the wrong value is given while the gauge value is still above 4, then images of the asteroid at 4, 3, 2 and 1 seconds away must be displayed before the game is over. However, if the wrong value is given when the gauge value is above 1, then only the image of the asteroid at 1 second away must be displayed, so the if statements in func_2_app ensure that the asteroid continues approaching the ship. With the medium difficulty game mode, the same basic operators are used, but the multiplication and division operators are used more readily and are employed in longer equations to increase the challenge and test the player's mental math ability. Lastly, the hard difficulty utilizes all the same operators as before, in addition to the factorial operator and differential operator, the latter of which will supply the player with an equation that they must differentiate. Displayed here are images that I used for the game. Images I found of a cosmic background, a spaceship, an asteroid, and an explosion, all edited and combined in various images which were employed in the game. They were then downloaded and resized on the design section of the app designer so that when they were sequenced together, movement was created.